Hello, Hotel. So today's lesson is the first lesson on the introduction into probability. So today we're going to be able to find the numerical probability of events occurring or not occurring. Some of the keywords you may see today are event, fractions, and mutually exclusive. We'll dig a little bit deeper into mutually exclusive later, but for now you'll be dealing with event and fractions. So some of the key important reasons that we learn probability is for real life application in sporting events, for insurance, for how much they're going to charge on insurance due to probability of events occurring or not occurring. And today we're going to be dealing with some examples on dice and red balls and green balls being picked from a bag. Okay, so first things first, we need to identify specific probability laws. So the first one you'll be dealing with is the probability scale. In maths, we use the number to describe the probabilities. So on the scaling ranges from 0 to 1, where 0 means that the probability of an event happening is impossible, and 1 meaning that the probability of the event happening is definite. So if we meet between these two at the middle at half, that means the probability of an event occurring is 1 in 2, a half. An example of this would be flipping a coin. You either have heads or you have tails. So the probability of getting a heads is a half, or the probability of getting a tails is also a half. Okay, so how do we actually calculate probability? So probability is defined as the desired outcomes divided by the total outcomes, and that is this equation here. So let's have a go at an example and you'll be able to see how we incorporate this equation into a probability question. So first things first is, how do we denote probability? How do we actually write it? So what we do is we write a P for probability with an open bracket, and I'm going to write down what our outcome is, getting a head on a fair coin. Okay, so the probability of getting a head is equals to the desired outcomes divided by the total outcomes. So what is our total outcomes? Our total outcomes are two options. We can either get heads or we can get tails. So we have two options. Two results, more like it, I should say. So the outcome that we are looking for is a head. How many heads can we get on a head or tail coin? And that is 1. We can only get one head. So our probability of getting a head is a half. Okay, let's go through some examples. So we have 3 examples on the board. Let's deal with the first one. What is the probability of getting a 2 on a die? A die is singular for a dice, by the way. So probability, again, we need to denote it as P with an open bracket, getting a 2, close bracket. So the total outcomes on a die, again, don't forget, that's 6. And how many 2s can we get on a fair 6-sided die? That is 1. There's only one possible 2 that we can get. Okay, what is the probability of getting an odd number on a die? Probability of odd equals to, how many outcomes do we have? We still have 6 on a die. How many odd numbers are there on a die? There is 1, 3, and 5. So in total we have 3 possibilities. So that is 3 over 6. Can we simplify this? Yes, we can. We can simplify that to 1 over 2, which is a half. Guys, just remember, in mathematics, we don't put the equals on the side of this equals, we put it directly below. I just didn't have any space here, but just make sure you put it directly below. Okay, so let's deal with the final one. What is the probability of getting an odd number on a 2 or a 2 on a die? So probability of odd or a 2. Again, we have 6 possible outcomes. However, we're looking for an odd number or a 2. So let's list our odd numbers first. We have 1, 3, and 5. Also, we may potentially get a 2. So in total, we have 4 outcomes that we desire. So that is going to be represented as 4 over 6. Can we simplify this again? Yes, we can. We can divide top and bottom by 2. And that gives us 1 over 3. So our probability of getting an odd or a 2 on a die is a third. Let me just rewrite that a bit better. Here you go. Okay, what I would like you to do is, once I finish speaking, is to pause the video and have a go at finding the probability of picking a red and also find the probability of picking a blue. Once you're finished, resume the video. Okay, welcome back. So again, let's recall our definition for calculating probability. It is the desired outcomes divided by the total outcomes. So in this case, our total outcomes, we have one, trying a different color. Let's try it in black. We have 1, 2, 3, 4, 5, 6, and 7. So we have 7 possible outcomes. We can pick one of these 7. So our total outcomes is 7. How many reds do we have? We have 3 reds. So that would be 3 over 7. Okay, what is the probability of picking a blue? Again, we still have 7 possible outcomes. And our desired outcomes, we have 1, 2, 3, 4 blues. So our probability of picking a blue is 4 over 7. Okay, so what is meant by mutually exclusive? So mutually exclusive means that 2 events cannot occur at the same time. So a nice example of this would be that heads and tails cannot occur at the same time. You either get a head or you get a tails. So an example of a not mutually exclusive event is getting a 5 or an odd number on a die, because you can either get a 5 or odd, you can get them at the same time. So what do probabilities add up to? We know that total probability adds up to 1, so if we recall our scale from the first or second slide, we know that probability lies in the range between 0 and 1. But total probability, if we add up all the probabilities of events, they add up to 1. So now we're going to deal with a question: what is the probability of not getting a 4 on a die? So the way in which we do this is we take the total probability, which is 1, the total probability, and we take away the probability of getting a 4. So the probability of getting a 4 is 1 in 6. So I'm going to explain that again. Is what is the probability of not getting a 4? That is the total probability, which is 1. Take away the probability of actually getting a 4, which is 1/6, and that will leave us with the probability of not getting a 4, which is equals to 5/6. So guys, if you're wondering how we got the 5/6, we need to convert that 1 into a fraction. So 1 as a fraction is 6 over 6. Take away 1 over 6, and that gives us 5/6. So that's how we done it. You can write it as either one of these two. Okay, what I would like you to do is, once I finish talking, to pause the video and have a go at calculating the probability of not getting an even number. Then once you have finished that, calculate the probability of not getting a 1 or a 2 on a fair-sided die. Okay, welcome back. So let's recall what it said in the previous slide. The total probability adds up to 1. So if we do 1 take away the probability of actually getting an even number, that will leave us with the probability of not getting an even number. So the probability of getting an even number is a half. So I'm going to do 1 take away a half. And 1 take away a half is equals to a half. So the probability of not getting an even number is a half. Again, the same principle applies here. If we do the total probability of an event occurring, which is 1, and take away the probability of getting a 1 or a 2, that will leave us with the probability of not getting a 1 or a 2. So the probability of getting a 1 or a 2 is 2 in 6. So if we do 1 take away 2/6, that will leave us with 4/6, which is also equivalent to 2 thirds. Okay guys, remember mathematically we do not put the equal sign next to the equation. What I'd like you to do is put it below. Unfortunately I didn't have enough space on this, but make sure you put your equal sign below every time, not across. Okay, so what I would like you to do is to have a go 4 sub-questions from the red section and have a go at doing 2 out of these 3 green questions. Once you have done, can you please upload a picture of your solutions onto class charts? If you have any problems, please message a member of staff on class charts. Also, if you have a look below, you'll see a link here that says wordwall.net. There is a little quiz that I would like you to have a go. The link should be attached onto class charts. I'll attach the link. What I'd like you to do is go onto class charts, click on the link and have a go at the quiz. I'd like you to take a screenshot or a picture of your results and upload that onto class charts too. Good luck.